Hi mga ka-numbers! Welcome back to Weighing RB channel. Today we'll be discussing the rules or laws of exponents. Before we dig deeper into the laws of exponents, please don't forget to like, comment, share, and subscribe to Weighing RB channel. Before we go along, I would like you to remember that the only way to learn mathematics is to do mathematics. That is why usually on my videos, I am giving you a part wherein it's your turn to do. Let's take a quick look at these rules of exponents or laws of exponents. First is the multiplication rule. Second, division rule. Third is the power of a power rule. The fourth is the power of a product rule. Next is the zero exponent, negative exponent, power of a fraction, and the fractional exponent. Don't worry, I will be discussing this one by one. If you are ready, let's go. The first rule is the multiplication rule. It says that a raised to x times a raised to y is equal to a raised to x plus y. Meaning that when you are getting the product with the same base, we keep or just copy the base. Since they are the same, then add the exponents. So to better understand this, let's take an example. Here it is 5 raised to the third power times 5 to the sixth power. In expanded form, we can write it down as 5 times 5 times 5. That is 5 raised to the third power. Multiply it by 5 to the 6, which is 5 times 5 times 5 times 5 times 5 times 5. So we multiply the base 6 times by itself. Or we can do is that we just copy the 5 and then count how many 5s do we have or how many times did we multiply the base. Which is, if we count, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So meaning we have 5 raised to the 9th power. Or getting the exponents, we could just have 5 raised to 3 plus 6, which are the exponents of the two terms. So our final answer would be 5 to the 9th power. Easy, right? So remember that when multiplying like bases, just add the exponents. Now it's your turn to do. Try this. I'm giving you 20 seconds. You can start now. Are you done? Let's check your answer. So since we have negative 3 as your base, we can multiply that 3 times because this is negative 3 raised to the third. So negative 3 times negative 3 times negative 3. Multiply it with negative 3 raised to the fourth power. And that would be negative 3 times negative 3 times negative 3 times negative 3. We multiplied the base 4 times by itself. So if we count that, we can have 1, 2, 3, 4, 5, 6, 7. So that means our answer should be negative 3 raised to the 7th power, right? Or we can also have the exponents, which are 3 and 4. We can just add them if you don't like to make it like an expanded way. So we copy the base, which is negative 3, and then add exponents, which are 3 and 4. So we'll have negative 3, you can use parentheses and then raise it to the 7th power. Or we can simply write negative 3 and then raise to the 7th power, which is the small number at the top right of the base. So that's it. Negative 3 to the 7th is our final answer. Let's now move on to the second law or rule, which is the division rule. This is also called quotient with the same base. When dividing like bases, keep the base the same and subtract the denominator exponent from the numerator exponent. So we have a raised to the x power divided by y raised to the y power is equal to a raised to the x minus y power. To better understand this, let's take an example. So we have 2 to the 7th power divided by 2 to the 4th power can be rewritten as 2 to the 7th power over 2 to the 4th power. So remember that the bar is also a symbol for division, so we can always use that. Expanding 2 to the 7th would mean we multiply 2 7 times by itself, and then 2 to the 4th would mean we multiply 2 by itself 4 times. So since we said that we have to subtract the exponents, we can also cancel 4 twos because it says 7 minus 4, right? So we can cancel 4 twos here on the numerator, and then this can also be cancelled because like 4 minus 4, so it will now be 0, and then what was left is 3 twos, right? So that means we have our answer as 2 to the 3rd. So writing down the base, since they have the same, and then writing the exponents as a subtraction, so we can subtract 7 minus 4. Will we have the same answer as 3 twos? Yes, it is, because 7 minus 4 is 3. And then copying the base, which is 2, we just have 2. And then the final answer is 2 to the 3rd power. Always remember, when dividing like bases, we copy the base and then we subtract exponents. Now it's your turn. Please try this. A to the 5th divided by a to the 3rd. Or you can rewrite that as a to the 5th power divided by a to the 3rd power. You can have 10 seconds to answer. You can begin now. I bet you are done, so let's check your answer. A to the 5th means we are multiplying a 5 times by itself, and then a to the 3rd would mean multiplying a 3 times by itself. So since we will be subtracting the exponents, we can just cancel 3 from the 5a's, so, and then 3 from the denominator, so we've got 2a's, right? So applying your rule or your law, we can have a, which is the base for the two terms. They are the same, so we just copy a, and then we just subtract the exponents, which are 5 and 3. So 5 minus 3 is 2. That is why our final answer is a raised to the 2nd power. Did you get that? Perfect. Let's now move on to the third law or rule, which is a power of a power. When raising a base with a power to another power, keep the base the same and multiply the exponents. So a raised to the x raised to the y power is equal to a raised to the x times y power. So to better understand this, let's take this example. 2 raised to the 3rd raised to the 4th power would mean 2 to the 3rd is multiplied 4 times. So in expanded form, we can have 2 to the 3rd times 2 to the 3rd times 2 to the 3rd times 2 to the 3rd. And since they have the same bases, we can just copy the base and then add their exponents. This is like the first rule, right? So if you add 3 plus 3 plus 3 plus 3, that will be equal to 12. And that is why our final answer would be 2 raised to the 12th power. However, you can just have this as the shortcut, and applying this rule, we just multiply the exponents. So we copy the base, which is 2, and then multiply the exponents, which are 3 and 4. So 3 times 4 is 12. That's why our final answer is 2 raised to the 12th power. Easy, right? So remember, keep the base the same and multiply the exponents. Now it's your turn. Do this in 10 seconds. You can go ahead. I bet you are done. So remember that we are multiplying the exponents. So we still have 2 as the base. So 2 to the 3rd raised to the 2nd power would mean 2 to the 3rd times 2 to the 3rd. We are multiplying the base twice itself. Or we can also have 2 raised to the 3 plus 3 because we have the exponent as 3, and then we multiply it as twice itself. And applying the rule, we can now have 2 raised to 2 times 3. 2 times 3 is 6, so that is why our final answer would be 2 raised to the 6th power. So if you are correct with this, great job. Let's now have the power of a product rule, which is the fourth law or rule of exponents. So we can have x times y raised to the 8th power, which is a and th, is equal to a raised to the 8th power times y raised to the 8th power. Or on the other side, we can also have a raised to the nth power times b raised to the nth power is equal to a times b raised to the nth power. So always remember the power has the th. And now let's learn more by having this example. 4 raised to the 2nd power times 3 raised to the 2nd power. Here the powers are the same and the bases are different. So expanding 4 to the 2nd power would mean 4 times 4, and 3 to the 2nd power is 3 times 3. To make the bases the same, we can have 4 times 3 times 4 times 3. 4 times 3 is equal to 12. That is why we have 12 times 12. And that could be written as 12 raised to the 2nd power. Here we observe that in 12 raised to the 2nd power, the base is the product of bases 4 and 3. So that means we can multiply 4 and 3. So here how it is. We can multiply the bases, which are 4 and 3. So 4 times 3 is 12. And then keep or copy the exponent, which is 2. So we can have the final answer as 12 raised to the 2nd power, or the value is 144. I believe you are ready for your turn. So try to do this for 10 seconds. You can start now. Are you ready? So let's check your answer. Expanding your 4 to the 3rd times 2 to the 3rd would mean 4 times 4 times 4 times 2 times 2 times 2. And making them with the same bases or with the same base, we can have 4 times 2 times 4 times 2 times 4 times 2. And 4 times 2 is 8. That is why we can multiply 8 times 8 times 8. And that would be equal to 8 to the 3rd. Or multiplying the two different bases, which are 4 and 2, we can multiply 4 times 2. That would be equal to 8. And then we just copy the exponent, which is 3. That's the shortcut or the easy way. I hope you get that. Moving on to the next law or rule, which is the negative exponent. This is the fifth one. So we have a raised to the negative x power equal to 1 over a raised to the x. And on the other side is 1 over x raised to the negative a power is equal to x raised to the a power. So a as in ATH. Okay, so this says that negative exponents in the numerator get moved to the denominator and become positive exponents. And negative exponents in the denominator get moved to the numerator and become positive exponents. So only move the negative exponents. So let's take a look at this. 2 raised to the negative 5th power. So remember that since this is a whole number 2, the denominator is always 1. So that means the negative 5 exponent is in the numerator. So to make it positive, we will move the negative 5 to the denominator. So that is why we have 1 as the numerator now over 2 raised to the 5th power. So notice that it becomes positive. And if we will be multiplying 2 times 2 times 2 times 2 times 2, which is 2 raised to the 5th power, we can have 32. So the final answer will be 1 over 32. Let's have another example. How about when the negative exponent is in the denominator? So we'll just do the other way around. It's like applying the inverse rule. So 1 over 3 raised to the negative fourth power would mean 3 raised to the fourth power, which is now a positive. So remember the 1 which is on the numerator of our problem is now moved at the bottom. However, we usually don't write it, okay? Especially when it's the denominator. So a whole number is automatically having 1 as its denominator. So finally, we can have 3 times 3 times 3 times 3. And if you multiply that, we can have 81. So the final answer is 81. And let's do remember this. Negative exponents mean factors remain, but they are in the denominator. Or it can also be in the numerator. It's just, it depends on where is the negative exponent. Now it's your turn. Try this. I know you can. 4 raised to the negative 3. You have 10 seconds to do it, so you can start now. I bet you are done, so let's check your answer. So since this is 4 raised to the negative 3, we can have it as 1 over 4 raised to the third power, which is now a positive. Or expanding 4 to the third power, we can now have 1 over 4 times 4 times 4. 4 times 4 times 4 is equal to 64. That is why our final answer will be 1 over 64. Easy, right? Now, the sixth law or rule is the zero exponent or power. So if the exponent is 0, then you always get 1. So a to the 0th power is equal to 1. Or 9 to the 0th power is equal to 1. Let's have these examples. 8 raised to the 0th power is equal to 1. And then if we have negative 67 as the base, raised to the 0th power, it is still 1. The square root of 2 raised to the 0th power is equal to 1. And 0.36 raised to the 0th power still equals 1. And if it is a fraction, which is negative 1/3 raised to the 0th power is equal to 1. So any base raised to the 0th power is equal to 1, except with 0. So 0 raised to the 0th power is undefined. So for non-zero x values, a zero exponent means 1. You can do this now for 10 seconds or just maybe 5. You ready? Go. What is your answer? If you say 1, that is correct. Perfect. We are almost through. This is the 7th law or rule, and that is the power of a fraction rule. So we have a over b raised to the x power equal to a raised to the x over b raised to the x. This is also called quotient to a power. So when raising a fraction to a power, distribute the power to each factor in the numerator and denominator of the fraction. So if you notice, we distributed the x exponent to a, which is the numerator, and the x exponent to b, which is the denominator. Let's move along. Example is 3/4 raised to the second power. So remember that we are distributing the exponent, which is 2, to the numerator, which is 3. So 3 raised to the second power is equal to 9, because 3 to the second power is 3 times 3. And then we also have to distribute this exponent to the denominator, which is 4. That is why we have 4 raised to the second power. And 4 times 4 is equal to 16. The final answer then is 9 over 16. At times when necessary, we can reduce our answer to the lowest term, but since we have 9 over 16, that cannot be reduced anymore to lowest term. So we have the final answer as 9 over 16. Remember, distribute the exponent both to the numerator and denominator. Now you're ready to go. Try this. 1/2 raised to the 4th power. You have 10 seconds to do that. You can start now. Are you ready? Let's check your answer. So since we have exponent of 4, we multiply the numerator, which is 1, 4 times by itself. 1 times 1 times 1 times 1 is equal to 1. And then the denominator, which is 2, we have to multiply itself 4 times. So 2 times 2 times 2 times 2 is equal to 16. So the final answer is 1 over 16. Did you get it correctly? Amazing. Yay! So we are now on the last rule or law of exponents, and that is fractional exponent. So it says that a raised to the x over y power is equal to the white root of a raised to the x power. Don't panic, this will be easier than you think. So, in fractional exponent, we observe that the exponent is in fraction form. Example, a raised to the 1 over n. A is the base and 1 over n is called exponent or power. And we can read this as nth root of a. We can better understand this with this example. 81 raised to the 1/2 power. So 1, which is the numerator of the exponent, is the power, and then the 2 is the root index. So what does this mean? It means that 2 becomes the index, which is the small number outside the radical sign, and the base, which is 81, goes inside the radical sign, and the 1, which is the power, goes with the 81, which is the power of 81. So, however, why don't we see 1? Because when we are raising a power to 1, that is not necessarily be written out. So it's just okay, or it is automatically 1. And then at times also, we don't need to write 2 as the index because we know that 2 is a square. So that is why we just can write it as a square root of 81. However, for the sake of showing you where these numbers or where this fraction goes, that is why I have written this. So the square root of 81, and if you're getting the square root, you will get 9 as your answer. However, we will not be discussing square root at this point. And yeah, maybe I'll be discussing this square root on the next video of mine. And now, please do remember that the denominator of a fractional exponent is the index of a radical. Let's have another example, and that is 16 raised to the 3/4 power. So remember that the 16, which is the base, goes inside the radical sign, and you have to use 3 as the power. And the 4 will be your index. And it will look like this. So the 4th root of 16 raised to the 3rd power. So notice that we have put the 3 as the power, and then the 4, which is the denominator, as the index. All right? So I hope you get that. Now you're ready to do your turn. 8 raised to the 2/3 power. I'm giving you 5 seconds. You ready? Did you get this answer? The cube root of 8 raised to the 2nd power. Why is this so? Because we said that 2 will be the power and 3 will be the index. That is why we have 3 outside the radical sign, and that is cube root, and then 8 raised to the 2nd power. I hope that is learned now and understood. As always, I would like to end this video with a summary of what we have learned today. Remember, these rules of exponents are laws of exponents. Beside each rule is an example wherein you will be able to get back whenever you forgot something or you just wanted to review it. First rule is the multiplication rule. So remember that since they have the same base, you just copy the base and add their exponents. Division rule is almost the same. So you just copy the base and then you subtract the exponents. That's the difference. Third rule is the power of a power rule. It means that you are multiplying the exponents and just copy the base. Fourth rule is the power of a product rule, meaning that you are distributing the exponent to each of the bases. You have different bases, but you have same exponent. Next thing, the zero exponent. So this is the easiest one because whatever is the base when raised to the zeroth power, it will always be equal to 1, except with 0 as a base because 0 raised to the zeroth power is undefined. Next, negative exponent. So if you have a negative exponent, you do the inverse rule. So if the negative exponent is in the numerator, you have to put that in the denominator so that it will become positive. And the other way around, if the negative exponent is in the denominator, you have to put that in the numerator so that the exponent will become positive. Power of a fraction. So if you have a fraction base, you just have to distribute the exponent to both of the numerator and denominator. Last, fractional exponent. So it just means that you have to raise that to the fourth power, third power, whatever it is, but remember that the denominator becomes the index and the numerator of the exponent is the power. So it goes with the base. So that's how you will remember everything. And whenever you forgot something, you can just get back to my video. I hope this is very useful for you. Remember this, you are amazing. And whatever you wanted to do, you can do it. Even if it's the most difficult problem in mathematics, you can do it. Thanks for watching. Don't forget to like, comment, share, and subscribe to Weng RB channel. And if you would like notifications or updates on all of my videos, please click the notifications bell. Bye! Till next time. Thanks and God bless.